This week we are looking at secondary growth, which is the production of woody tissues. So everything that becomes wood and then everything that wood becomes is what we are thinking about this week. And this will be in eudicot stems and roots. We'll focus on stems. We don't really look at roots very much. We're not looking at monocots because monocots do not undergo the same type of secondary growth. Most monocots don't undergo any kind of woody tissue making, but some do, and bamboo is always my reference for that. Bamboo is a grass, but makes a very tough woody material, but through a different process. Little overview. First we'll look at that general progression just as a review of how secondary growth occurs in the roots. Then we'll look at that same progression or a similar progression that happens in the shoots, and we'll look at cross sections of each stage along the way. Then we will look at different types of wood. We will learn some terms for how to talk about like a wood cookie, which would be a secondary stem cross section. And then last we'll talk about dendrochronology. All of this should come up in your lab, so it will hopefully be useful to you. Here we have our root kind of series of cross sections. So we start out in this really early primary growth. We're still in that growing root tip where we haven't even differentiated into tissues really yet. We have our primary tissues, but they're still meristematic. We don't have, I guess, mature tissues. So you can think about in that root long section, where would we be? Would we be in the zone of division, the zone of elongation, or the zone of maturation? If we don't yet have our primary tissues, we just have our primary meristems. Those are the correct words. Then we're moving up in the root as we go kind of back in time, right? As that root continues growing downward, we're looking at later parts in development. So we're looking at this progression of growth. So we could take a root tip and do cross sections through it, and we'd be going back in time. The tip is the earliest point because that's currently growing, and then cells later in that tip have already differentiated and matured. So we can go from our primary meristems here that would be down in the zone of division. And then we can go to the zone of, we're probably skipping through elongation here directly into maturation, where we have all of our primary tissues. You can see we have this yellow layer here, the pericycle. That's going to be involved in both secondary meristems that get produced. That pericycle is going to join up with this residual procambium here and form the vascular cambium. The pericycle will also take part in forming the cork cambium, because we're going to lose all of our external layers. So the epidermis, the cortex, and the endodermis, which is just the innermost layer of the cortex, are all going to be sloughed off. See here, they're just like, imagine a snake shedding its skin, right? Sloughing off. So as the pericycle starts forming the cork cambium, that cork cambium is going to produce two different types of tissues, and one of those tissues is cork. Cork cells are dead, and they're filled with suberin, which is that waxy material that was also part of the Casparian strip. So that seals off that layer. So now those external layers, the epidermis and the cortex, aren't connected to the vascular tissue anymore. So those cells die, and that whole skin on the outside gets sloughed off. And when we start producing more from these lateral meristems that are growing outward instead of growing upward. So our pericycle makes the cork cambium, and it teams up with the residual procambium to make the vascular cambium. Those are our two secondary meristems. The vascular cambium makes our secondary vascular tissues, secondary xylem and secondary phloem. And our cork cambium makes our periderm tissues. So it'll make cork to the outside and pheloderm to the inside. Pheloderm is also sometimes called phelogin. It's not super important to me that you remember that term, but that's just the other kind of storage tissue that the cork cambium makes. Okay, so that was roots. We're going to switch gears over to shoots. So here we have a look at the sort of progression of growth that you would be seeing. We still have primary growth happening in our growing tips, and then as we move down this shoot, we're going to older stages that have now started secondary growth. So here in primary growth, we see those familiar primary tissues. We have these vascular bundles here that form a sort of ring around the stem cross section. And then we'll have cortex on the outside. We'll have pith in the middle, and then there's pith rays that connect the cortex and the pith. We have a layer of meristematic tissue running through those bundles all the way around, and so that we're going to call the fascicular cambium when it's within the bundles, and the interfascicular cambium when it's in the pith rays. So that is going to be super important for going into secondary growth, because that's going to become our vascular cambium, which again will produce our secondary vascular tissues, xylem to the inside and phloem to the outside. So primary growth, the epidermis is the outermost layer, vascular tissue still forms these distinct bundles. Once we start secondary growth, the epidermis is again going to go away because we're forming this dead, hardened layer underneath it, and we're going to cut off the epidermis from the rest of the tissue. So the epidermis sloughs off, and we start to form our first periderm. So the periderms are what we're going to call this combination of cork cambium, and phyloderm. Okay, so I'm going to wait to talk about this 2 years of secondary growth part because we'll get there. So right now we're just looking at this transition from primary growth to secondary growth. And this is a little bit blurry, but I like this representation as well because it color codes on one side the cross sections that we're used to seeing, and then it shows us in a long section how those tissues sort of diverge from each other through the stem as it grows. I'm going to pause because my nose is really itchy. Okay, itch scratched. So notice that the primary xylem here in blue and the primary phloem here in orange, there's vascular cambium in between them. We would call that the fascicular cambium. That fascicular cambium becomes vascular cambium, and as it does, it starts producing secondary tissues, and it's going to push away those primary tissues because we're growing laterally now. So the primary xylem gets pushed to the inside with the pith, which is going to be a very small part of our stem cross section, and then our primary phloem gets pushed to the outside. So we're going to start making secondary xylem and secondary phloem as we push those away. So you can see that here in the cross section. In this light blue, we have this new secondary xylem, and in this light orange, we have this new secondary phloem. So this is what that would look like if we were to have an up-close version of our secondary stem here. We're in early secondary growth. We've just started making our secondary tissues. So this right here is the vascular cambium, and it's all labeled in this nice diagram on the left. Below that, just below it, we would have our secondary xylem. These pockets right here represent our primary xylem. You can see it being pushed away toward the center. And then up here, we would have secondary phloem. And the secondary phloem is, not secondary phloem, the primary phloem is hard to find. There's sometimes these really dense regions of phloem fibers where you can kind of find those pockets of primary phloem, but eventually it'll get dedifferentiated and become part of the cork cambium and then become part of the periderms. So we'll eventually lose all of this phloem that gets made. These living cells can get dedifferentiated, becomes kind of like stem cells again, and then turn into tissues that we'll be using in the periderm. So all of our phloem can get reused, but our xylem cells are dead. So they, once made, stay, and they stay on the inside, and so we start growing outward. And we're just depositing basically all of these dead tissues in the inside of this woody stem. So this is early secondary growth. We still have an epidermis, and you can see right under the epidermis there's a bunch of collenchyma for this early growing stem. Then we'd have some cortex. We don't really see layers of the cork cambium forming. Our vascular cambium forms first. The cork cambium will start to form from our cortex, as opposed to the pericycle, as it would be in the root, because we don't have the pericycle in the shoot. So we start forming cork cambium out of cortex, and that is where we'll see the epidermis go away once those periderms start to form. But that happens a little bit later in secondary growth. So early secondary growth, we are forming the vascular cambium and the secondary vascular tissues. I will pause right here and we will look at the rest of this in the next video.